Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Corn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hello there, Herman and Corn. So I was looking lately with great envy at the AI supercomputer that you can fit on your desk. It's called the NVIDIA DGX Spark. And what's very interesting about this particular piece of hardware is that it's a local AI inference machine and more. And it does really fit on your desk. It's quite a remarkably compact piece of hardware for what it can do, which is run models up to 200 billion parameters. So for people like me, more used to trying to squeeze these tiny quantized models onto our much inferior GPUs, this thing is like something from the space era. But it made me wonder, I think I found this out because I've always had, or lately been looking into having a local AI server. Now that my wife is doing some local AI workloads, and I'm doing a little bit of it as well. And I guess it's not the first thing you'd kind of think about when you're looking to how can I run AI, but when you begin to sort of look at the API costs, especially getting into the more complex image to video stuff, the equation tends to change a little bit, and actually can do so at not a dramatic level of scale, such as even two people both using AI tools for work. And I imagine that there's going to be a lot more of that in the near future from people who are using these tools in their day-to-day work. And it doesn't become such a crazy proposition to run an AI computer. Now, this is the thing that I came across, and it was very interesting to me because I always wondered for the big models, if you talk about, running a kind of relatively small quant of Mistral or Llama, it's not that difficult to do in the sense that my pretty ordinary desktop computer is able to do that without really much effort. But if you talk about running big models and doing video generation and stuff that isn't quant, suddenly you get into another world of complexity with requirements for multiple GPUs, power systems that go beyond just plugging in your computer to the wall, cooling systems, and it's a whole kind of thing. The more professional use for offline or air-gapped AI is in certain industries with sensitive data requirements. And I can imagine that if a government were using AI locally for some context, that they're not going to be running it on individual workstations. So what I'm getting to is, besides this kind of very intriguing little tool from NVIDIA, for organizations today that have a real and serious need for beefy local AI inference, what kind of machines are they typically deploying, and who do you get them from? Like, if you want to run a big model of an AI tool locally in a business, and you're going to have all these requirements for power and whatnot, who do you call up to install one of those things in your company?
Welcome to My Weird Prompts. I'm Corn, your ever-curious host, and as always, I'm joined by the encyclopedic Herman. Herman, how are you today?
I'm excellent, Corn, and quite stimulated by today's prompt. It touches on an area that's often misunderstood but incredibly important for the future of AI.
Oh, you know it. Our producer, Daniel Rosehill, sent us a fascinating prompt this week, sparked by his discovery of the NVIDIA DGX Spark essentially, an AI supercomputer you can fit on your desk. Now, that phrase alone, AI supercomputer on your desk, sounds like something out of science fiction, doesn't it?
It certainly does, Corn, and it highlights a significant shift happening in the AI landscape. While the cloud has been dominant for AI workloads, there's a growing need, and now the technological capability for powerful AI processing to happen locally. The DGX Spark, capable of running models up to 200 billion parameters, is a prime example of this.
200 billion parameters? That's just mind-boggling. I mean, my desktop can run some of these smaller quantized models, like a Mistral or a Llama, and that's already impressive. But this DGX Spark sounds like a whole different beast. What exactly are we talking about here when we say local AI inference machine and more? Are we saying everyone's gonna have one of these on their desk soon?
Well, hold on, Corn. That's where we need to introduce a bit of nuance. While the on-your-desk part sounds appealing, we're not quite at the point where every home user will have a full-blown AI supercomputer next to their monitor. The prompt specifically mentions inference machine, which is distinct from training machine. Inference is about running already trained models, making predictions, or generating content. Training, especially for those 200 billion parameter models, requires even more massive resources, often still in the cloud or specialized data centers.
Okay, that's a good distinction. So, it's about using the AI, not necessarily building it from scratch on your desk. But even for inference, why is local such a big deal now? I mean, we've got cloud services galore. Just spin up an instance, pay by the hour, and you're good, right?
You're right. For many use cases, cloud services are perfectly adequate, even preferable. They offer scalability, managed infrastructure, and often lower upfront costs. However, for certain applications, the API costs, especially for more complex tasks like continuous video generation or highly iterative processes, can quickly become prohibitive. Moreover, latency becomes an issue. If you're relying on a round trip to a data center every time you need an AI inference, that delay can be unacceptable for real-time applications.
Ah, latency. So, if I'm trying to, say, process a live video feed from a factory floor, or have an AI respond instantly to a medical scan, a round trip to Google's servers might just be too slow.
Exactly. Think about autonomous vehicles, real-time fraud detection in financial institutions, or even local security systems monitoring hundreds of cameras. Every millisecond counts. And beyond latency and cost, there's a critical third factor that local AI addresses: data privacy and security.
Oh, that makes total sense. If you're dealing with sensitive corporate data, or even classified government information, you might not want that ever leaving your physical premises, let alone bouncing around on a public cloud. Herman, you mentioned that Daniel, our producer, was looking into this partly because of API costs, especially for complex image-to-video stuff. That sounds like a consumer use case almost. Is this local AI server concept mostly for individuals trying to save a buck, or is it a bigger enterprise play?
It's definitely a bigger enterprise play, Corn, though the cost-saving aspect appeals to individuals too. For someone like Daniel, who might be exploring complex creative workflows, those API costs for heavy image-to-video generation can quickly add up, turning what seems like a casual experiment into a substantial bill. He's trying to justify a local setup on a personal or small business scale. But for larger organizations, the drivers are much more pronounced.
So, for regular folks, if I just want to generate some pretty pictures or write a quick email, the cloud is still the way to go, right? Like, a desktop AI supercomputer isn't going to suddenly replace ChatGPT or Midjourney.
Not for those specific casual use cases, no. Cloud services offer convenience and accessibility. But the moment you start talking about proprietary data, high volume, continuous processing, or stringent security requirements, the calculus changes dramatically. This isn't just about consumer convenience, it's about strategic infrastructure decisions for businesses and governments. You see this in industries ranging from manufacturing, where AI might monitor production lines for defects, to healthcare, analyzing patient data without it ever leaving the hospital network.
Okay, but for normal people, does that really matter? I mean, isn't it just a niche thing for big companies with super secret stuff? I'm still picturing this DGX Spark and thinking, can I get one for my gaming setup?
That's where I'd push back, Corn. While it might seem niche, the implications are broad. The ability to process data at the edge, where it's generated, whether that's a factory floor, a smart city sensor, or a remote military outpost transforms what's possible. And no, for gaming, you're looking at a different GPU architecture and software stack entirely. A DGX Spark is not designed for pushing frames per second on the latest blockbuster video game. It's a highly specialized piece of hardware for deep learning.
Good point. I guess I'm getting ahead of myself, as usual. But let's say a business does need this beefy local AI inference. What are the actual requirements beyond just having a powerful GPU? Because Daniel's prompt hinted at multiple GPUs, power systems, cooling systems. That sounds like more than just plugging in a new graphics card.
You've hit on something vital there. It's not just a souped-up PC. For true enterprise-grade local AI, you're looking at a holistic system. Firstly, power. High-performance GPUs consume a lot of electricity, requiring specialized power supplies and possibly dedicated circuits. Then there's cooling. These chips generate immense heat, so sophisticated liquid or air cooling systems are essential to prevent thermal throttling and ensure longevity. Beyond that, you need high-bandwidth internal interconnects between GPUs, like NVIDIA's NVLink, to ensure data flows efficiently. And finally, the software stack. You need optimized drivers, frameworks like TensorFlow or PyTorch, and orchestration tools to manage these complex workloads. It's a mini data center in a box, not just a desktop.
So, you're not just calling up your local computer store and asking for the beefiest AI machine, huh? This sounds like you need to talk to specialists.
Precisely. This isn't an off-the-shelf purchase for the uninitiated.
Alright, let's take a quick break from our sponsors.
Are you tired of feeling like your life is just happening to you? Do you crave an inexplicable sense of purpose? A vague feeling of, I'm doing something important, even if you're just staring at a wall? Introducing Egigo Boost Elixir, our proprietary blend of rare earth minerals, purified rainwater from a nameless mountain spring, and the secret ingredient, a subtle, almost imperceptible whisper of validation, will unlock your inner CEO. Side effects may include an improved posture, an increased tendency to nod sagely, and a sudden, undeniable urge to tell strangers your life story. Ego Boost Elixir, because sometimes you just need a little something to feel more. No, we don't know what it does either, but you'll feel it. Buy now.
Right, thanks Larry. Anyway, Corn, picking up on your point about specialists, that's exactly where the market for these local AI supercomputers gets interesting. It's not just about what NVIDIA offers directly, like the DGX line. There's a whole ecosystem of system integrators, specialized hardware vendors, and enterprise solution providers who custom build and deploy these systems.
So, who are these players? If a company decided, okay, we need this for our sensitive data or our real-time applications, who do they call? Are we talking about Dell and HP or smaller niche companies?
It's a mix. The big enterprise players like HPE, Dell Technologies, and Lenovo do offer specialized AI servers and workstations, often incorporating NVIDIA's GPUs, but they're typically more generalized data center solutions. For truly bespoke, air-gapped, or ultra-high-performance local AI setups, you're often looking at specialized integrators. These companies understand the intricacies of power delivery, advanced cooling, network topology for massive data throughput, and cybersecurity for isolated environments. They often work closely with silicon providers like NVIDIA to deploy optimized stacks.
Air-gapped AI, that sounds like something out of a spy movie. Can you explain that a bit more? Because it really zeroes in on the security and privacy aspect.
Absolutely. An air-gapped system is physically isolated from unsecured networks, like the public internet. Imagine a computer that is literally not connected to anything else, making it incredibly difficult for external threats to access it. For AI, this means models are trained and run entirely within a secure, isolated environment. This is paramount for government agencies handling classified information, defense contractors, critical infrastructure operators, and even financial institutions dealing with highly sensitive trading algorithms or personal data that absolutely cannot risk exposure.
So they're sacrificing the convenience of cloud access for ultimate security and control. That must be a significant investment, both in hardware and the expertise to maintain it.
It is. The total cost of ownership for such systems includes not just the hardware, but also the specialized personnel required for deployment, maintenance, and security. However, for organizations where data integrity and security are non-negotiable, it's a necessary investment that far outweighs the perceived benefits of cloud elasticity. The risk of a data breach, especially with AI models that might contain sensitive embedded information, is simply too high.
It's a trade-off then. But for an enterprise looking at this, how do they even begin to assess the ROI? Like, how do you put a price on not getting hacked or real-time decisions that save lives?
That's the challenge. The ROI isn't always a direct cost saving. It's often about risk mitigation, compliance, operational efficiency, and unlocking entirely new capabilities. For instance, in manufacturing, if local AI can detect a flaw in a product instantaneously, preventing thousands of faulty units from being produced, that's a massive saving. In healthcare, an AI that quickly processes a diagnostic image at the point of care can lead to faster treatment and better patient outcomes. These are tangible benefits, even if they don't appear as a direct line item reduction in a cloud bill.
And we've got a caller on the line. And I think I recognize that voice. Hey Jim, what's on your mind today?
Yeah, this is Jim from Ohio. I've been listening to you two go on and on about all this local AI supercomputer stuff, and frankly, I think you're making a mountain out of a molehill. My neighbor Gary got one of those fancy new self-driving lawnmowers last week, and it just uses the internet no problem. I don't see why everything needs to be so complicated with all these air gaps and power systems. It's just computers, isn't it? Also, it rained all day yesterday here in Ohio, so Gary's fancy mower didn't even get to cut the grass. What's the point of all this if it doesn't just work?
Thanks for calling in, Jim. I understand why it might seem overly complex. But the scale and sensitivity of data we're discussing for enterprise AI far exceed what a consumer device like a smart lawnmower handles. A lawnmower might send telemetry data, but it's not processing millions of confidential financial records or real-time sensor data from a nuclear power plant. The just works mentality works for consumer tech, but for critical infrastructure, reliability, security, and performance are absolute imperatives.
Yeah, and Jim, even for consumer things, think about when your internet goes out. Your smart lawnmower probably can't do much then, right? With local AI, if the internet connection is flaky or non-existent, the critical systems keep running. It's about resilience, too.
Resilience. Schmesilience. My old push mower always worked, rain or shine. You guys are just overthinking things as usual. It's like trying to fix a squeaky door with a whole engineering team when all you need is a bit of WD-40. Anyway, my cat Whiskers just threw up on the rug, so I gotta go deal with that. I still think it's all a bit much.
Thanks for the call, Jim. Always a pleasure. We appreciate your perspective.
Jim raises a valid point about overcomplication from a certain perspective, but it really underscores the vast difference in requirements between casual consumer tech and industrial or government-grade applications. These local AI supercomputers aren't about simple convenience. They're about enabling missions and protecting assets.
So, bringing it back to practical takeaways for our listeners, whether they're an individual thinking about local AI or an enterprise, what should they keep in mind?
Firstly, understand your actual needs. Are you dealing with sensitive data? Do you require extremely low latency? Are cloud API costs becoming unsustainable for your specific workload? If the answer to any of these is a strong yes, then local AI becomes a very compelling option.
And don't just think GPU. It's not just about a powerful graphics card. It's about the entire system. Power, cooling, network, and the specialized software stack that goes with it. You're building a mini data center, not just a souped-up PC.
Correct. And for enterprises, don't try to go it alone unless you have significant in-house expertise. Partner with system integrators and specialized vendors who understand the intricacies of deploying and maintaining these complex systems. The upfront investment is significant, but the long-term strategic value can be immense.
And I think it's also worth noting that the landscape is constantly evolving. What seems like bleeding-edge hardware today might be standard in a few years, so staying informed about the latest developments in local inference hardware and software is key. This isn't a static field.
Indeed, we're seeing more optimized hardware and software, and even new approaches like federated learning that blend local processing with distributed insights. The future is likely a hybrid model, where cloud and edge computing work in tandem, each handling tasks best suited to its strengths.
Fascinating stuff, Herman. This prompt from Daniel really opened up a whole world of enterprise-grade AI that most of us probably don't even think about. It's not just about generative AI in the cloud anymore.
It certainly is a deep topic, Corn, and one that will only grow in importance. The ability to run powerful AI locally is transformative for security, efficiency, and unlocking new applications at the very edge of our networks.
Absolutely. And that wraps up another thought-provoking episode of My Weird Prompts. A huge thank you to Daniel Rosehill for sending in this week's prompt, always pushing us to explore the weird and wonderful world of AI.
And thanks to all our listeners for joining us.
You can find My Weird Prompts on Spotify and wherever else you get your podcasts. Make sure to subscribe so you don't miss an episode. Until next time, stay curious. Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.